Hi everyone. In this video, I'll be providing a brief explanation of what correlationships are and how we can use SPSS tool to test such relationships. To begin with, let me give you the scenario of testing relationship between age and the number of travels as an example. For example, we go out and do a survey of people and we ask them how old they are. The first person we run into says he or she is 30 years old and how many times they have traveled. Let's say they say we've traveled 3 times. So I will be here. The second person we run into says he's 18 and they have traveled 5 times. The other person we run into says 35 and has traveled um, 35 and has traveled 15 times. The other person we run into says 45 years old and traveled 23 times. So, and someone else we run into says he or she is 55 and has traveled 40 times. Another person we run into says he or she is 48 and has traveled 29 times. Another person we run into says he or she is 70 and have traveled 50 times. So the, as we can see on the scatter plot here, on the plot here, that the higher the age of a person gets, the more that their number of travels are. So with this type of relationship in a statistical terms, and for this type of relationship in statistical terms, we say it is a positive correlation. In a positive correlationship, when one variable goes high, the other variable goes high. So um, one variable mirrors the other variable. Let's say uh, the change of any change in one variable, I'm trying to come up with with the simplest terms to be able to explain this, as simplest term as possible to be able to explain this. So when the change in one variable is reflected in change in the other variable, that's the positive relationship. As we can see in this case, the more people we find with higher ages, the more number of travels our survey shows that they have had. Somebody has 18 years old have only traveled 3 times or 4 times, as opposed to someone who was 70 something years old and traveled 50 times. So we also have something we call negative correlationships. A negative correlationship is when we actually have when the change causes the opposite, when the change in one variable causes the opposite on the other variable. In other words, in this as we can better explain in this scenario, when someone's age goes down, the less they travel. So the more they travel. If someone's age goes high, or the less they travel. So for example, let's say we run into somebody who says they have traveled, they're somebody who's 73 years old and have traveled 5 times. You run into somebody else who says he's 20 years old and have traveled 45 times. Someone else is 25 years old and says he's traveled 53 times. And somebody else is 43 years old and have traveled 35 times. So the more, the less the age gets, the more the travel gets. Or the less the travel gets, the higher the age is. So when the increase in one variable causes decrease in the other, or when the decrease in one variable causes an increase in the other variable. So this is called a negative correlation. But remember, it's very important to know that correlationship is not causation. Just because somebody is getting older or younger, it does not cause them to travel. Rather, we should look at it in a way that it's just a correlationship. There may be other confounding relationship or confounding variables or covariables that may have contributed to this relationship, but not necessarily one variable causes the other variable to change. There may be other, like I said, other underlying contributing factors that may cause it, but not necessarily one causing the other. This is therefore it's very important while using correlationship tests or using the, while using the the lenses of correlationship in order to or correlations statistical studies to assess something. Keep in mind that you're not necessarily looking at studying a cause of something, rather the relationship of something. I'm hoping that this explanation was good enough. So now we can go to SPSS, since in this video I'll be using SPSS tool in order to test correlation. So I there's I'm there's these data from the Harvard University that I extracted onto SPSS, and it's a combination of 12 variables. It does not specify what country this data come from or what cluster of region. But it contains these information: family size, education in years, age in years, experience in years, number of months worked, race, region, earnings, family income, wealth, and savings. So I extracted these data points, which is 90, 100, from this website onto SPSS, where I'll be performing my correlations test. Remember that all those information are numerical data, maybe except for region of residence, that may be a nominal data. Everything else is just scale. SPSS knows them as scale. It depends on the tool that you use. Um, they each have the names that they use are not universal across data science, but a scale is pretty much the equivalent of what we call in R, or in statistical terms, numerical data. So these are the fields. So we have some questions here that we're going to ask. The first question we're going to ask: is there a relationship between years of education and earnings? In other words, does number of years in education that someone spends, does that have any relationship with their earning? So let's go ahead and test this relationship. Oh, sorry, I keep going to. So in SPSS drop-down menus, it's much easier to do this as opposed to R or SAS. So go to Analyze, go to Correlate, and click on Bivariate. Bivariate because we're looking at two data or two variables. Remember, univariate, bivariate, and multivariate. Univariate is when you're looking at one variable. Let's say you're looking at distribution of a variable, looking at the averages of a variable, or standard deviations, or anything else, in terms of descriptive analysis or explorative analysis. Bivariate is when you're comparing two variables or when you're studying two variables. Multivariate is when you're studying multiple variables. So in this case, it will be a bivariate analysis. So I'm going to use family size versus family savings. These are the two variables I'm going to test. Remember that Pearson needs to be checked because the because this is numerical data, number one. Number two, um, the assumption is that this is normal, which I've already tested. This is the distribution of all these variables are normal. They're not highly skewed. So make sure that in order to use Pearson, you have to make sure that the distribution of your variables are normal. If it's not normal, then we're not going to use Pearson as the right parametric test. Rather, we will use Taft, or Spearman for ranked, especially if you're looking at the ranked distribution where you have ordinal distribution, like number one, number two, number four. Each of those numbers actually represent a ranking of each value. Then you'll be using Kindle. So I'll have separate videos about those, but for right now, remember to use Pearson because you're looking at numerical data that has no order, and that the fact that they are normally distributed. These are the assumptions. Being normally distributed, they have to be randomly selected. Um, all right, and so on the options, you can click on mean standard deviations. We won't be needing them, but you can select it just in case you want to look at the distribution of each of these variables if you need to. It will be a two-tailed for the significance because we're looking at the significance on both sides of the tails. And also click on flag significant relationships in case there's something highly significant. SPSS will flag them for you. So just click on OK once you have both of the variables on the variable box, and it is going to take you to the page, the output. The output says that let's just forget about the mean and standard deviation. Look at the Pearson correlation coefficient. So the coefficient for family size, for the family savings and family size says that it is a negatively correlated, and it gives us this number minus 0.783. In statistical terms, it's called correlation coefficient, or in other words, the coefficient or the coefficient uh, metric of our correlationship. So at this, let me go to this file here. I wrote this metrics to interpret what the coefficients actually indicate. So if it's a 1, it's a perfect positive correlation. If it's between 0.90 and 0.99, it's very strong positive correlation. And if it's between 0.70 and 0.90, it's a strong positive correlation. It's not very strong, it's not weak, but it's in there. If it's between 0.50 and 0.70, it's medium positive correlation. And it's between 0.30 and 0.50, it's a weak positive correlation. If it's between 0.01 and 0.30, it's negligible positive correlation. And 0, it's actually absolutely no correlation. Same thing with the minus. If it's -1, it's perfect negative correlation, and it's minus 0.90 and minus 0.99, it's very strong negative correlation. And I've explained what the negative correlation and what positive correlationships are at the beginning of this video. So let's go to our output and look at it's minus 0.783 with 2 stars. So SPSS flagged this for us to say that this is actually significant at the level of 0.01 two-tailed. I was looking at a significance level of 0.05. If this is significant at the level of 0.01, then this means that it is significantly correlated, and it's statistically significant in terms of correlation. So it's a very good news. And since it's 0.783 and it's minus, let's go back to here. So it falls in this range and it's strong negative correlation. And about this metrics, I wrote this metrics. It's not a standard. It depends on the industry, or depends on the academic discipline where you're doing your research and analysis. But I thought this would be something ideal to break down the coefficients. Some people have some sources have broken them down in the increments of tens. Some have done in the increments of 30, but and given them two or three categories. I wanted to give them. I wanted to be fair and break them down at least in at least 7 different classifications, and give each classification fair share of the strength of the relationship. So again, this is not a standard, but remember that the coefficient will always be between 0 and 1. The or minus zero on zero, minus zero, and minus one. So the more it is close to one or minus one, the more strong the relationship is. The more, the further it is away, the further it is from one, the less strong the relationship is. So now let's go to our output. It's a very strong negative correlationship. It means as the family size goes down, as the family size goes down, the savings goes up. Or in other words, as the family savings goes down, the family size goes up. So it is one variable goes high, the other variable goes down. So we just tested the first one. Let's go and test the second one. The second is number of households in a family and their savings. So number of households in a family and their savings. That would be, let's go to analysis. Oh, before I check the second question, let's go look at the chart. That's very, very important in studying a correlationship. It's very important to use scatter plots to visually look at the distribution of both variables. So in this case, the family size will go to y-axis or x-axis, doesn't really matter. So put both variables that you're testing in y and x axis. You don't have to put titles. If I won't put titles in this video to save time, but you can play around with the titles or any specifications you want to add. Pretty simply click on OK, and you're going to see the chart here. And as you can see, and as our correlation test indicated, when one variable goes high, the other variable goes down. One variable goes down, the other variable goes high. As you can see in this case, as the family size goes down, the savings goes high. That means families that are less in number are more likely to have more savings than family that are high in numbers. All right, let's go check the second test now, which is number of households in a family and their savings. So that would be, let's go back to correlate, bivariate again. That would be families, number of, what was the question again? I apologize. Number of households in a family and their savings. Oh, this was the second one we just tested. So that will be years of education and earning. So let's go check years of education and earning. Years of education. So it will be earnings. There you go. So again, it will be Pearson because it's a parametric test and it's normally distributed. And flag the significant correlationships should be checked. There you go. Now we are looking at 4.67. So and it's at least significance, it's below 0.05. It also flagged this relationship at the significant level of 0.01, two-tailed. So it's statistically significant, but since the correlation coefficient is 467, let's go check 467. 467 is falls somewhere here between these two. So we can say it's between weak and medium positive correlationship. We can actually even call it medium positive correlation because it's very close to 50 because it's not standardized. So if something is since this is halfway between 0 and 1, and if something is halfway between, 0 being the least and 1 being the highest, then we can say it's medium. It's a median. So it's a medium positive it has a medium positive correlation. In other words, when the years of education goes high, the earning goes high. Let's clarify this through visualization. Again, going to scatter plot, simple scatter plot. Click on define, and it was families. It was earnings versus years of education. There you go. Okay, there you go. As you can see, one variable goes high, the other variable goes high. As a test significance indicate, it's a positive correlation. So when the earning goes high, the number of education goes high. When the number of education goes high, the earnings goes high. If one goes down, the other one goes down. All right, so let's go check the third question now. The third question is the family size and education years. All right, let's see if there is any relationship between education years, number of years in education, and family size. All right, let's go to SPSS again. Correlationship, bivariate, reset it. So that was family size, family size, and education years. Okay, education years. It'll be this one. Again, it will make sure Pearson is on, checked here because it's a parametric, normally distributed numerical data, and flag the significant correlation and click on OK. There you go. So there's a bad news here now. The correlation coefficient is actually very, very low. It's below -1. So it's minus 0.138. So this means that this relationship, as our metrics explains, is actually negligible negative correlation. It means it's not something that we can consider, or it does not, it's not significant at all. So not only that, but also as you can see, the statistical significance shows that this is also not statistically significant. So it's one is 0.172. This is above 0.05, even above 0.10. Excuse me. Let's look at this relationship on the chart by going to scatter plot, simple scatter plot, and then it was family size versus years of education. There you go. As you can see, there is no trend, there's no shape in the way that these data points are scattered across the chart. So, um, as both the test and the chart indicates, there is no relationship, and for number three, we can say that there's no relationship between family size and education years, and that this relationship is not so statistically significant. Now, there is for the family and their saving, there is there is there is strong statistical significance as well as the coefficient correlation shows that that the coefficient correlation shows that it's a strong negative correlation as well as it's statistically significant. Same thing with years of education and earning. It's both statistically significant as well as it has a positive um, strong it has a moderate positive uh, a moderately strong positive correlation. So these were the three studies which we have done on three research questions or case studies. Final thing is that sometimes when you have a, a number of variables, for example, in this case where we have almost 10 variables, and you would like to run or you would like to check each variable against the other variable to check their correlationship. And if you have to if you have to go to analyze and check the correlationship each time or visualize each one of them against the other each time, it could be it could be time consuming. It also has a likelihood of errors. So one of the features that SPSS has is just like R, it allows you to do matrix scatter or matrix plot. So pretty much you can put all of your variables here. Let's say you would like to run all these four against each other. So put all four variables on matrix variable box and then pretty simply click on OK. So this will give you a matrix. In other words, this will allow you to check all four variables for correlationship against each other at a glance. Well, it's not showing these because this is SPSS has the tendency that it does not fit everything onto the same um, window, so you'll have to go and change the size a little bit. Maybe there you go. So you'll have to change the size a little bit to be able to look at all the variable names. So as you can see, family size versus itself, it's blank, of course. Family size versus education years, we just checked. There's no trend. Family size versus age in years, no relationship. Family size versus experience years, a little bit of, but not much. Education years versus itself, nothing. Family size we already checked. Education years versus age in years. Yeah, we can say actually this can be a good case of a negative correlationship here, as if education years goes down, age years goes down. That means that people with that that are younger have more education than people who are older. So pretty much the scatter metrics, allows you to be able to again visualize and look at all the variables that you would like to study them for correlationship at one glance, at one look. And this will be a good start, a good practice in going into studying correlationship between multiple variables. I hope this video was helpful. I'm hoping that I did not miss anything. Um, Thank you so much and have a great day or night.